Good morning, sir. My name is Harshita. I am from Computer Science and Engineering Department. Topic is about storage structure. Outline: Introduction to storage structure, types of storage structure, primary storage, secondary storage, tertiary storage, memory hierarchy structure, magnetic disk, redundant array of independent disk, conclusion. Introduction to storage structure. A storage structure is the method or framework used to store, organize, and manage data in a computer system. It determines how data is arranged in memory or on storage devices, such as hard disk, SSDs, or cloud system. At its core, the storage structure in DBMS determines how data physically resides on a disk and how quickly it can be accessed. They have factors like data layout and indexing. Types of storage structures. A database are stored in file formats which contain records. At physical levels, the actual data is stored in electromagnetic format on some devices. These storage devices can be broadly categorized into three types. Primary storage. The memory storage that is directly accessible to the CPU comes under this category. CPU internal memory, fast memory, and main memory are directly accessible to the CPU as they are all placed on the motherboard or CPU chipset. These storage typically very small, ultra fast, and volatile. Primary storage requires continuous power supply in order to maintain its state. In case of a power failure, all its data is lost. Secondary storage. Secondary storage devices are used to store data for future uses or as backup. Secondary storage includes memory devices that are not a part of the CPU chipset or motherboard. For example, magnetic disk, volatile disk, hard disk, flash drives, magnetic tapes, optical disk like DVD, CED. Secondary storage is non-volatile and used for long-term data. It is slower than primary storage but offers higher capacity. Tertiary storage. Tertiary storage is used to store huge volumes of data. Since such storage devices are external to the computer system, they are slowest in speed. These storage devices are mostly used to take the backup of an entire system. Optical disks and magnetic tapes are widely used as tertiary storage. Examples: optical storage, tape storage. Optical storages like CDs and DVDs that use lasers for reading and writing data. Tape storage like magnetic tapes used for sequential data access, ideal for long-term backups. Memory hierarchy. A computer system has a well-defined hierarchy. A CPU has direct access to its main memory as well as its inbuilt registers. The access time of the main memory is obviously less than the CPU speed. To minimize this speed, mismatch cache memory is introduced. Cache memory provides the fastest access time and it contains data that is most frequently accessed by the CPU. The memory with the fastest access is the costliest one. Memory hierarchy structure. The memory hierarchy in DBMS balances speed, cost, and capacity. Here we can see the memory hierarchy structure. At the top are CPU registers and cache memory, which are fastest but most expensive. Moving down, RAM, secondary, and tertiary storage offers increasing capacity but slower access speeds. Magnetic disk. Hard disk drives are the most common secondary storage devices in present computer systems. These are called magnetic disk, but they use the concept of magnetization to store information. Hard disk consist of metal disk coated with magnetization material. These disks are placed vertically on a spindle. A read or write head moves in between the disk and is used to magnetize or demagnetize the spot under it. A magnetized spot can be recognized as 0 or 1. Hard disks are formatted in a well defined order to store data efficiently. A hard disk plate has many concentric circles on it called tracks. Every track is further divided into sectors. Each sector on a hard disk typically stores 5 to 12 bytes of data. Here we can see a sample pic of magnetic disk. Redundant array of independent disk. RAID or redundant array of independent disk is a technology to connect multiple secondary storage devices and use them as a single storage media. RAID consists of an array of disks in which multiple disks are connected together to achieve different goals. RAID levels define the use of disk arrays. RAID works by splitting data across multiple disks, so if one disk fails, the data can still be recovered from the other disk. For example, this is similar to a making copies of a book and sharing with friends. If one friend loses their copy, he can still reconstruct the book from the other copies. Levels of RAID. RAID 0. In this level, a stripped array of disks is implemented. The data is broken down into blocks and the blocks are distributed among disk. Pros. High performance and full utilization of disk space. Cons. No fault tolerance. If one disk fails, all data is lost. RAID 1. RAID 1 uses mirroring techniques. When data is sent to a RAID controller, it sends a copy of data to all the disks in the array. RAID level 1 is also called as mirroring. Pros. High fault tolerance. If one disk fails, data can be recovered from the other disk. Cons. Higher cost due to the need for additional disk. RAID 2. RAID 2 records error correction code using Hamming distance for its data stripped on different disks. Pros. Error detection and correction. Cons. High cost and complexity, not commonly used. RAID 3. RAID 3 strips the data onto multiple disks. The parity bit generated for data word is stored on a different disk. This technique makes it to overcome single disk failures. Pros. High data transfer rates. Cons. Requires an additional drive for parity. Slowly performance for small files. RAID 4. In this level, an entire block of data is written onto data disk and then the parity is generated and stored on a different disk. Pros. Allows recovery of one disk failure. Cons. Cannot recover from multiple disk failures. RAID 5. RAID 5 writes whole data blocks onto different disks, but the parity bits generated for data blocks stripped or distributed among all the data disks rather than storing them on a different dedicated disk. Pros. Better random write performance. Cons. Longer recovery time. Cannot survive concurrent drive failures. RAID 6. RAID 6 is an extension of level 5. In this level, two independent parities are generated and stored in distributed fashion among multiple disks. This level requires at least 4 disks to implement RAID. Pros. Can survive two concurrent disk failures. Cons. Slower write performance requires an extra space. Conclusion. Storage structures are designed to optimize performance, reliability, and cost. Primary storage ensures fast access for active data. Secondary storage handles long term needs, and tertiary storage supports backup and archiving. RAID, also known as redundant array of independent disks, enhances data reliability, availability, and performance. Different rate levels offer trade offs between speed, fault tolerance, and cost. Thank you.